All right, so continuing on in our discussion of sets, we talked about what a set was last time. It is a collection of objects. In this class, we're mostly dealing with collections of letters and numbers to keep things nice and relaxed. So now what we're going to talk about is a little bit more detail about sets and their structure, and we're going to deal with the idea of what's called a subset. Okay, so like sub, we know that prefix from like submarine. It's something underneath. Okay, a subcategory. And so a subset is related to a given set. So for instance, we are going to use this set for a bunch of our examples. It's a nice simple set. A is going to be defined to be the letters A, B, C, D, E, F. And so now here's what we're going to spend the bulk of our time talking about today, and whatever questions, whatever, anything you have. So we're going to define what's called a subset. So we're going to define a new set B that we are going to call a subset. So set B is a subset of set A, if and only if, that means these are the only conditions that this applies for, if every element of set B is also an element of A. Didn't really give you a large enough line there, I apologize, but I think we'll all make do. So this new set we're talking about a set in relation to our first set, our set A, called a subset. And what a subset means is every element of the new set is in the original set. Okay, so what we're doing is we're taking some subcategory, okay, some collection from the original set. That is what it means to be a subset. The notation for a subset is B is a subset. It's like a U that's on its side with a bar underneath it. Kind of like in arithmetic, the less than or equal to sign that we just saw a few minutes ago on the board. So B is a subset of A. That's what that symbol is communicating to you, because math people love symbols. So here's what we're going to do in this exercise. I'm going to help you with the first one, and then you're going to do the others. Okay, so in this exercise for each set, we are going to determine if the set is a subset of A that is defined above. So again, A is the set A, B, C, D, E, F. So set B is the set with B and D in it. So here's the question. In this set B, are both of these elements here elements of set A? Do you see them in set A? Yes. Okay, so what we've done is we've grabbed a couple things from set A, thrown in a new set. So I'm going to say yes, and then I'm just going to write B is a subset of A. That's how that notation works. So just going to take these one at a time. Okay, so the next one, go ahead and answer the same question for set C that's right below. Is set C a subset? Don't shout it out. Let's give everybody a chance to think about it, and then we'll answer. All right, so same question for set C. Set C has the elements A, D, and F. Are all three of those elements in set A? Yes, so is set C a subset of A? Yes, it is. Okay, so again, I'm going to answer yes, and then I'm going to write C is a subset of A. Fantastic. All right, go ahead and do it for the next one. Set D. All right, set D, the elements are A, E, I, O, U. Is every element of D also in set A? No. A and E are, that's fine, but I, O, and U, these three elements right here are not in A, so is set D a subset of the original set? No, so this one's a no. And then just like we saw with element of in the last section, I can write D is not a subset by putting a line through it. Okay, just like a not equals or not an element of, D is not a subset of A. All right, next one, E. So E is the elements A, B, C, D, E, F. Is every element there also in A? Yes. In fact, what do you notice about E? E is has a specific relationship with A. How are they more specifically related than just being a subset? They're identical. They're equal sets. Yeah, fantastic. Great way to notice that. So E is a subset of A. So just like this, just to relate it to something that I think you are familiar with, if I wrote down this statement from arithmetic, 5 is less than or equal to 5. Is this a true statement right here? Yes, it is. Why is this a true statement? Is 5 less than 5? No, but 5 is equal to 5, the equal arrangement. So the same thing with my subset symbol. E is equal, that line right there means equal. E is equal to A. Okay, so just kind of trying to relate this new thing to something that I'm hoping you've seen before. Okay, the last one, I'm sorry about the way that this printed. It did not print like this on previous versions of, in previous semesters. This dotted box right here just means I didn't type anything. This is intended to be the empty set. So sorry about that. I'm looking at my notes from my previous semester and there's no dotted box in there. So they must have changed, the addition of Microsoft Word. So this is the empty set. So I want you to make a hypothesis because this is probably the one that will mess with your mind the most. So I'm going to give you 15 seconds. Is the empty set F? Do you think that is a subset? Yes or no? Don't shout it out. Let's just make a proposal. Okay, so this one is a little bit of a thinker. How many of you say, yes, it is a subset? Okay, that's pretty unanimous. How many say no, it's not a subset? Okay, that's what I was fully expecting because this is kind of a goofy one. Well, here is how this works. Remember, subset, the definition of a subset is every element of the set is also an element of the bigger set. So like when we saw set B, element B was in the original set, D was in the original set. So he said it was a subset. Now, the empty set has nothing in it. So by definition, since there's nothing in here, everything that's in here, which is nothing, is also an element of the original set. So what that means is yes, F, the empty set, is a subset of A. So just a thing to remember is that the empty set is always a subset. Okay, I understand that that one's a little goofy. Okay, are we doing okay so far? Anybody got a question? What a subset is? A subset is you're just going into your original set and you're taking some number of the elements of the original set and making a new set. That's what a subset is. Okay, so there's one more thing that we're going to define today, and then we're just gonna do a little more work. Okay, a proper subset. Okay, so we're adding this new word proper onto the idea of a subset. So set B is what's called a proper subset of set A, if and only if, again, that means these are the only conditions that this happens. If every element of set B is an element of set A, that is just the definition of a subset. So what this first says is, if you're going to be a proper subset, you first have to be a regular subset. Okay, that's the first criteria. But then the second criteria, set B is not equal to set A. That's basically the only subset we eliminate here in a proper subset, is no longer do we care about the equal set. And we notice this in the notation. So the notation for a proper subset, notice on this notation, what's missing here that was included on the notation for a regular subset? The equal bar, right? So it is described for us in this notation. Okay, so again, that's just like with arithmetic, where we would say this is a true statement. 3 is less than 5, right? So I'm just again relating to some notation that I think you're familiar with, the less than symbol. That's kind of how the proper subset symbol works. So here's what I would like you to do. Is the next exercise. It's the same 5 sets that we just talked about, B, C, D, E, and F. Again, in F, that should be the empty set. And what I would like you to do is go through each of those and determine, is it a proper subset? Yes or no? And I'm going to give you about 90 seconds to go through that. All right, so let's go through one at a time. Help me out here. So set B. Is B a proper subset? Okay, I heard both. So let's go through the 2 criteria. The 2 criteria. First criteria is B a subset, meaning is every element of B a element of A? And that is true. B and D are both in the original set A, which is not on the screen right now, but it's at the top of your notes. Is this set right here, is this equal to the original set? No, it has fewer elements. So that's what makes this a proper subset. So yes, B is a proper subset of A. Well, if you got that one wrong, it's okay. You get to try again with this very next one. So C, is C a proper subset of A? Again, what are the 2 characteristics? First, is it a subset? Well, yes, A, D, and F are all in the set A that's at the top of the page. And then C is not equal to. There are things missing from the set. So again, yes, C is a proper subset of A. How about D? Is D a proper subset? No, because we saw in the first time around, it wasn't even a subset. Okay, so it fails right away. So no, it's not even a subset. So D again is not a subset of A. I can just put a slash through it to indicate not a proper subset. How about E? Is E a proper subset? Okay, why is it not? You are 100% correct. Because it's the equal set. Yes, it's a subset we saw earlier. It has all the same elements of A, but it has all of the elements of A, it has every single one. So E is not a proper subset of A. Great job. And then the empty set. Is the empty set a proper subset? Yes, because it is not the equal set. And I told you just a few minutes ago, even though it's a little funky to think about, that the proper subset, or excuse me, the empty set is always a subset. Okay, so F, meaning the empty set, is a proper subset of A. Great job. All right, so now just to think about this backwards, okay, so we're hopefully able to identify if something's a subset, if something's a proper subset. So now just to go the other direction, the next exercise down at the bottom of the page says, okay, I've defined a new set A for you. It's the odd numbers 1 through 17, and I just want you to identify two proper subsets. Okay, there's lots of answers to this. Okay, so identify two proper subsets, please. I'll give you about a minute and a half to do that. All right, so like I said, there are lots of answers to this. In fact, we'll talk about on the back page how many answers there are to this particular problem right here. But somebody give me one of your proper subsets. Go for it. Okay, the set with 1, 5, and 9 in it. Great. All three of those elements are elements of A, and you don't have all the elements of A. So perfect. Somebody give me another one. 3, 7, 13. Fantastic. Same thing. I'm going to give you another one. Here's a nice quick one. The set with 15 in it. Excellent. Somebody give me one more, just so we have a little variety here. 1, 5, 11, and 17. And again, all of these subsets are proper because they don't include everything. You could also have written down the empty set. And if you don't know if what you wrote down, if you didn't answer because maybe you're feeling a little like maybe you got it wrong, just raise your hand while we're doing the next problem and I'll run and make sure that you got a couple proper subsets written down. So there we go. Anybody got a question before we turn the page? All right, well, at the top of the next page is just another problem like we've been doing. All we're doing is practicing these two little definitions so that we get it right. So again, we're going to use that same set A that we just talked about a minute ago. It's the odd numbers 1 through 17. And what I would just like you to do for the sets that I've listed is identify, is it a subset? Is it a proper subset? Is it both or is it neither? Okay, so just like basically, I've just combined what we did on the front page into one problem. Again, set F. I'll have to fix that. So if you're watching the video, I'm probably going to change that to the null symbol so that it's a little clearer. But that right there is the empty set. So I'll give you a couple minutes to work on that. If you need anything, raise your hand. I will run to you and help you. We'll see how you do. All right, so I'm gonna get started. If you're still working, keep working. If you're done, I just try to cut the middle when I give you time to work a problem. So if you're not quite done, there's nothing wrong with you. There's no shame in that. Okay, so just trying to keep things rolling forward here. So set B, 3, 11, 13, 19. Is that a subset, proper subset, both or neither? Why are you saying neither? You're 100% right. Yes, set B contains the number 19. 19 is not in the original set A, so it is not a subset. Therefore, it can't be a proper subset because it has to first be a subset. So I'm going to write the word neither right here. Does anyone have a question about why that is neither before I move on? We have plenty of time today, so don't let me move on if you have a question. All right, set C. It's both. It's 1, 3, 9, 11. All of those are in set A. So that means C is a subset of A, but then it doesn't have everything in set A. So it also means it's a proper subset. It's both. Does anyone have a question about why that is both? If you didn't get it the first time around, do you see why it's both? Okay, great. D is just the set with 13 in it. What's the answer there? Again, both. It's a subset because 13 is in set A. I can clearly see it right there. Okay, so D is a subset of A, and then D does not contain every element from A. So D is also a proper subset of A. Fantastic. Great job. I'm just going to keep rolling forward. I told you the first time we met, I love questions. Okay, there's nothing wrong with questions. Questions mean you're learning. Okay, so I'm going to leave it up to you to raise your hand when you have a question. You are not an interruption to me. You're a reason I'm here. Okay, so don't feel insecure about that. All right, set E. What did you answer for set E? Yeah, 16 and 18 are not in set A, so it's not a subset. And because, again, since it's not a subset, it can't be a proper subset. This one is neither. Great job. How about the empty set, F? It's both. Yep. F is a subset because I told you F is always a subset, and also it doesn't contain all the elements, so it is a proper subset of A. Great job. Last but not least, G. What did you answer for G? It's only a subset. Yes. G is a subset, but why isn't it a proper subset? Well said. It contains all of you that spoke gave the right answer. It has everything that is in set A. That's why it is not proper. I'm going to write that parenthetically just so that you know we didn't skip that. It's not proper. Okay, great job. All right, so now hopefully you feel pretty confident about a subset and a proper subset and what they are. We're going to wrap up this section talking about, okay, now that I see what a proper subset, what a subset is there any way to tell without listing them all out how many subsets a particular set has? And it's going to turn out that there is. And what we're going to do is you are going to help me. We are going to use a little bit of inductive reasoning to figure out the answer to this question. So I've got a couple of examples here, and we're small sets, and we're going to list everything out. And then what you're going to help me do after that is make a hypothesis. Okay, so we're going to do what's called inductive reasoning. We're going to look at specific examples, and then we're going to make a generalized statement. Okay, we're not proving anything because we're not at that level of math, but we're going to be right in what we say. So here's what we're going to do. I've got a set with one element in it. It's just the set that contains A. So I'm going to list out all the subsets. There's not a whole lot. So the first subset is the empty set. It is always a subset for me. And then the second subset is the set with A. It's the equal set. Are there any other elements there that I can throw in and make a subset? No, we're done. How many is that? How many subsets did I make? 2. Okay, so I'm just going to write this over here. There's 2 subsets. You with me so far? Doing okay? All right. I'm gonna help you with the next one, and then I'm gonna set you free to do your best on the third one. So what happens if I have a set with 2 elements? Well, I've got now the set with A and B in it. So what I'm gonna do again is I'm gonna list out all the subsets. So again, I'm gonna start with the empty set. Somebody give me another subset of this. Okay, A, the set with A in it. How about another one? Okay, the set with B in it. And there's actually one more, and it's what? Yep, the set that's equal with both of them in it. Yes. Okay, when I count that up, how many subsets is that? Okay, I'm going to write that on the side. I'm going to give you 60 seconds to make a hypothesis. Write down all the subsets of this set with 3 elements that you can think of. And then we will compare notes, and then we will count them up. All right, I'm just going to get started here. I'm going to try to be systematic about this. There's definitely different ways to come up with all these. So what I'm going to do first is I'm going to list out the empty set. That's always the one I start with. Then I'm going to list the subsets that have one element in them. So that is the set with A in it, which you probably wrote down, the set with B in it that you probably wrote down, the set with C in it that you probably wrote down. Now I'm going to go through and I'm going to write down all the sets that have 2 elements in it. So the first one I can think of is A and B. What's another one with 2 elements in it? Okay, A and C. And then there's actually one more with 2 elements in it. What is that going to be? Yeah, B and C. Great. And then there's only one more subset. We've done all the ones with 1, all the ones with 2, the 0, empty set. The last one is, yep, the equal set. Okay, let's count it up. How many subsets is that if I have 3 elements? Okay, that's 8 subsets. Now, I'm not cruel, so I'm not going to make us list out all the subsets when I have 4 elements, but we are going to use this now to see if we can figure out the pattern. So when I had 1 element, there were 2 subsets. When I had 2 elements, there were 4. When I had 3 elements, there were 8. What's happening each time? Yeah, to go from one element to 2 elements, what happened to the number of subsets? It doubled. To go from 2 elements to 3 elements, what happened to the number of subsets? Doubled. So if your life depended on it, which it does not, but if it did, how many subsets would you guess now when I have 4 elements? Yep, that's exactly right. There'd be 16 subsets. And that keeps happening. So if I don't have it written on the paper, but if I wrote down a set with 5 elements, how many subsets would that have? 32. Keeps doubling. Now, that's great. You've just used what's called inductive reasoning. You have created a general principle out of looking at some specific things, and I'm going to actually make it a little bit more for you. So here's what we're gonna notice about this. I'm going to relate this to a little arithmetic. I'm going to write all these as a power of 2. So 2 in arithmetic can be written as 2 to the first power. 4 in arithmetic. How many 2's is 4? How many times do I multiply 2? 2. It's 2 times 2, so it's 2 to the second power. How about 8? 8 is 2 to the what power? Third. And 16, our hypothesis here. 16 is 2 to what power? Yeah. So notice, this becomes a nice kind of simple. Simple doesn't mean easy. Okay, but mathematically simple just means it's not super complicated. Notice what happens. When I have one element, the number of subset is 2 to the first power. When I have two elements, the number of subsets is 2 to the second power. When I have three elements, the number of subsets is 2 to the third power. When I have four elements, the number of subsets is 2 to the fourth. So here's the general statement. If you have n elements, n is just a number, any number. If you have n elements, the number of subsets is going to be what? Do you think? Perfect. 2 to the n power. Yes. Love it. So we're going to skip the next question for just a second. We'll come back to it real quickly. But right below that, there's an exercise. The exercise says, how many subsets would a set with 8 elements have? Okay, so real quick, make your hypothesis to that question, and we'll see how you did. If you have a calculator, or go ahead and use your phone calculator, that's fine in this instance. So if I give you a set with 8 elements, it would have how many subsets? Where'd you get 64? It's going to be 2 to what power? I have 8 elements, so it's going to be 2 to the 8th power, yes. And then I go into my calculator. Okay. What I've got is a TI-30. This is what our bookstore sells, but any sort of scientific calculator will get you through this class. If you don't have a lot of money, Dollar Tree, they got their school supplies on sale, and they have a nice scientific calculator. It costs $1.25. Okay, yeah, Dollar Tree now everything's $1.25. It takes the fun out of it, but that's okay. And so if you do not know how to do exponents on whatever calculator you have, just see me after class. It'll take us literally 5 seconds to show you. But if you have this kind of Texas Instruments calculator, I'm going to put 2. That's my base. I'm going to hit the caret right there. It looks like a triangle without the bottom. That's the power symbol on this calculator. And then the 8th. And when I hit equals, that is 256. Is the number of subsets. So that would be a really mean project for me to make you list out all 256. But fortunately, I am not going to ask you to do that. I'm just asking you how many there are. I know you said 64. Just see where you win a foul. Okay, great. Just remember, mistakes are fine. That's learning. Where'd you make the mistake? Then you don't have to ever do that again. Okay, so here's the next question then. Now that we know that the number of subsets is 2 to the n power, and n is just how many elements are in the set, the next question is how many of them are proper subsets? Thinking about our example, if you look up at the top, the exercise we did, how many subsets are not proper? What do we have to exclude for proper subsets? The one that's equal. I'm going to ask you just to repeat this because you said the right word in there. How many equal sets are there? 1. Yes, there's only the one equal set. Okay, so how many proper subsets do you have? All you do is you subtract 1. The equal set. So for the problem we just did, the exercise, how many subsets would a set with 8 elements have? That was 2 to the 8th power. So then related to that is how many proper subsets would that set with 8 elements have? That's exactly right. We're going to subtract 1, and it's going to be 255 proper subsets. Uh-oh, my pen's running out of ink. All you're subtracting is the equal set. And there's only one equal set. It's kind of like up here. I'm just going to return to the exercise we did just a moment ago. Set C, that was both a subset and a proper subset. The set D was both a subset and a proper subset. But when I got down to G, G was the equal set. So G is a subset, but it's not proper because it has everything that was in the original set. And that's the only time that happens is with the one equal set. And that's why here, when I ask you how many proper, we subtract one. Just because we have plenty of time, we've got one more problem to do. I'm just going to flip over to the back of this and I'm going to just ask you to do another one more of these because I just want to make sure that we're all feeling nice and confident before we leave here today. So here's a potential question I could ask you. And I'm just going to paraphrase. How many subsets of a set with 10? Oops, you can't even see that because it's not on the screen. That's better. Now I'm a good professor. How many subsets of a set with 10 elements? And then after you've answered that, how many proper subsets? Okay, so even if you don't have a calculator, you can answer the first part generally. Okay, if I tell you a set has 10 elements, how many subsets does that have? How do I figure that out? Okay, it's going to be 2 to the 10th power. Everybody with me on that? Okay, that was the result of our inductive reasoning earlier. And now I'm going to go to my calculator because I'm not doing that in my head. So 2 to the 10th power is 1024. Okay, so there are 1024 different options of subsets. Great. And now of those 1024 subsets, how many of them are proper subsets? 1023. We just subtract one, that one equal set. That feel a little more secure in your brain? All right, we got just one more problem. We are going to apply this idea of how many subsets do we have. So it's kind of a little bit of an application problem right here. So here's the exercise down at the bottom. I'm going to read through it with you, and I'm going to show you how this is the number of subsets. This is there'll be a couple problems in your homework that are similar to this. So we've got our friends, the Fitzgeralds. They are installing an in-ground pool in their backyard. So good for them. They know it's hot in Florida and they want to be able to cool off. They can install the base model offered by the pool company. So all that's saying is they are definitely getting a pool. Okay. But then the pool company also has options. And they can get a pool cleaner, a solar cover, a waterfall, a hot tub, a fountain, a slide, or a diving board. Those are options. They don't have to get any of them. They don't have to get all of them. Okay, that's how this is a subset problem. Okay, they can pick all of them, none of them, two of them. They can pick some subcategory of those options. Does that make sense? Okay. So what we want to know is how many different variations of the pool are possible. So if you're the pool company and you got a big sign out in front of your door and you want to say, there are X number of possible pools you can get from us. Okay, that's what we want to do. Okay, so let's do this then. So we want to know then, basically what this is how many subsets of the options are there? So what this means is, okay, here are my options. I'm just going to throw some set braces around the options so that we see what the sets are right there. The pool cleaner, the solar cover, the waterfall, the hot tub, the fountain, the slide, the diving board. Yes. That's the question I'm going to answer for you right now. That is a beautiful question. I love it. Okay. So in this case, if this is the set of options, what does the empty set mean? What does the empty set means you're just getting the pool, nothing else, right? Does that make sense? Let me write that down because that's the common question right here. So in this case, the empty set, I'm just going to write my set braces with nothing in it. The empty set means we're just getting the pool. No options. So if I got the set with the slide and diving board, that would mean I'm getting the slide and the diving board added onto my pool. If I got the equal set, that would mean I'm going big and I'm getting everything added onto my pool. Are you seeing how this applies? That's great because that's why I got this problem. That's the hard thing to see. And once that becomes clear, when you get to the problems on the homework, they're all going to look, there's like 2 or 3, they're going to look like this. Okay, you just want to see how does this idea of sets apply. So now, how many subsets, how many different pools can this pool company sell? Okay, well, how many options are there? Let's count them up. There are 7 options. So that means that the pool company can sell you 2 to the 7th different kind of pool variations. Anything from the empty set, which is just the pool with nothing else, all the way to the equal set, which is you got everything. And 2 to the 7th, when I throw that down into my calculator, let me clear 2 to the 7th is equal to 128. So there are 128 different styles of pools that can be sold. Does that make sense? We feel okay with that? Remember, the reason we do homework is what happens now is everything's in your short-term memory and you feel pretty good about it, right? But what we want to do is we want to lock it into long-term memory. It's like anything else you do in life, whether you're an artist, whether you're a musician, whether you're an athlete, anything we do in life, we've got to practice so that we get to do it well and under pressure. When you come to the test, I don't want your short-term memory to fall out because that's what'll happen. Okay, tests, I understand. They're a stressful event. That's why we want to lock this stuff into long-term memory. So that's why we're going to do homework. So